Okay, so we're doing exercise 11A from the first year mechanics textbook, and we're looking at question 6. So we've got velocity as a function of time. And so we recognise that's a quadratic function, so that they want to know the time taken for the particle to come to instantaneous rest. So it's going to be at rest when its velocity is 0. It's saying instantaneous because immediately after that it'll carry on moving, so it doesn't stop completely. It doesn't stop permanently, I should say. Okay, so question 6a. So the function is that v is 8t minus 2t squared. So it's at rest when v is 0, and I'm going to take 2t out as a common factor. So it's at rest when t is 0 and when t is 4 seconds. And let's just double check. Okay, yeah, so it doesn't seem to say that we want two answers, but that's fair enough, isn't it? Because it starts at rest, so that explains that answer. So my actual answer to the question is 4 seconds. That's when it comes to instantaneous rest. Okay, then I want the greatest speed of the particle in that time interval. So let's just do a quick sketch. So it's a negative quadratic, and I've just shown that there's roots at 0 and 4. So that was what a rough sketch of v against, I don't know if you could see my screen, right? So that's what a rough sketch of v against t would look like. So I know from this calculation it's got roots at t is 0 and t is 4. So I've labelled those on. And I know it's a negative quadratic, so it's going that way. So the question was, in that time period, so between 0 and 4, find the greatest speed. Okay, so that's going to be here. So it's the vertex. So I could differentiate and find t and then use that to find v, stationary point. Could just put it into my calculator, but basically I want to complete this square. So I'm going to take out a common factor of minus 2, and then that will leave me with t squared minus 4t. So it's going to be t minus 2 all squared. You are absolutely fine just to get the vertex from your calculator. So, and then that's going to multiply out to minus 2 times t minus 2 squared, so plus 2 squared. And then I've got the minus 4 times the minus 2. So that vertex is at t is 2, v is 8. So the greatest velocity is 8 meters a second, and therefore the greatest speed is 8 meters per second.